Det är bara inledningen. Vi kommer att visa en svensktextad film här och ta upp lite saker, så kommer jag avsluta sen med ett jätteuppmuntrande budskap till dig som tror att du skall inte frukta för det som kommer. För att Jesus redan har vunnit segern och kommer att strida för oss. Vi hörs igen efter de här videorna som förklarar saker och ting som vi förstår kommer att slå ut hela systemet.
Vi har haft 2 starka jordbävningar senaste dygnet, först den tragiska i Marocko på 6,8 och så en till i Afrika på 6,6, samtidigt förökad seismisk aktivitet som visar sig både i små kluster och vulkanutbrott. Det är troligen en direkt konsekvens av de geomagnetiska störningar som visat sig i rymden senaste tiden, särskilt oroligheterna på solens korona. Mike, en troende forskare med massor av följare på YouTube. Något märkligt sker i rymden som vi kallar mikronovas, som vetenskapsmännen är förvånade över. Stjärnor slits plötsligt sönder och Plutos atmosfär börjar förändras och märkliga saker sker nu på Neptunus. Suspicious Observers med över 700 000 följare på YouTube. Nu skall vi lära oss hur rymden påverkar jorden, precis som bibeln säger i denna svensk textade video.
Space weather is the study of how the space environment is impacted by activity on the sun, and how those conditions then impact the Earth. This includes sunspots, solar flares, solar wind, coronal mass ejections, coronal holes, geomagnetic storms, and more. The closest most regular people get to space weather is hearing about the northern lights. Maybe they see them, the aurora. Some know it has to do with the sun and solar activity, but the details are elusive for those who don't dig deeper. So, let's pick up the shovel, shall we? The place to begin is with sunspots. These are highly magnetic areas on the surface of the sun. It's called the photosphere, and they are where the majority of space weather awareness begins. They can be tiny, up to bigger than Jupiter, and there are often many in one location. The appearance of sunspots runs on an 11-year cycle, sunspot maximum and sunspot minimum. Virtually no sunspots appear during the minimum, while lots appear during the maximum phase. How many appear during that maximum phase always varies, as you can see here in the amplitude variability over the last few centuries of observations, but the 11-year cycle does not change. That would be the wavelength of the pattern. These sunspots are the makers of the most exciting space weather phenomenon, the solar flare. But before we dig too deeply into the solar flare, we need to understand why these sunspots make solar flares. These sunspots are not simply surface features, but their effect goes high into the solar atmosphere, called the corona. There are large arching magnetic fields filled with plasma connecting positive and negatively charged sunspots, like a circuit. And when those fields interact at this area between the photosphere and the corona, called the chromosphere, there is brightly excited plasma visible in many of the sun's ultraviolet images. The interaction of those magnetic field arches is the most common cause of the solar flare. Since sunspots are constantly growing or shrinking and moving around in relation to one another, these arching fields have a tendency to interact. And when that happens, the highly energetic fields and electric plasma under the power of the star electromagnetically explode. By far, the most powerful events seem to follow a very specific pattern. There is a smaller release, and that smaller release causes a rapid growth of new and powerful fields, which grow too quickly, rise too quickly, allowing the arch to interact with itself and cause an explosive disruption of the circuit. These solar flares appear as bright flashes in the ultraviolet images, and this is the release of not only extreme ultraviolet light, but X-rays as well. These X-rays are actually the way we classify a solar flare, by how much X-ray energy is released in the wake of that electromagnetic explosion of the arching magnetic fields from sunspots. The scale rating, from lowest to highest, is A-class flare, B-class flare, C-class, M-class, and X-class is the largest. These flares can be further classified into 2 types, impulsive or short-duration flares and long-duration flares. The long-duration ones tend to be more explosive, and here on the X-ray flux chart from the GOES satellite, we can see a few impulsive C-class flares and then a long-duration M-class flare. When I say the long-duration flares are more explosive, this is what I mean. They produce coronal mass ejections, CMEs, plasma mass ejected from the corona and out into space. While solar flares ionize the upper atmosphere of Earth, it is the CMEs that actually deliver the electromagnetic punch to our planet. These can occur not only due to solar flares, but due to plasma filament eruptions. Large, thin, cloud-like structures high in the corona are also quite prevalent, and they can erupt as well. Both long-duration flares and the plasma filament releases can cause CMEs, and those CMEs enhance the solar wind. The solar wind is a constant plasma stream away from the sun, outward in all directions, happening all the time. But the CMEs enhance that plasma stream, delivering far more electromagnetic energy as they do so. This is not only what triggers those auroral events, but can also wreak havoc on our technology, from satellites to power grids and everything in between, if they are big enough. There is one more thing that can enhance the solar wind, and that is a coronal hole. They appear dark in the solar ultraviolet images, but they aren't holes that look down into the sun. They are simply empty areas in the corona, ergo the name coronal holes. They are empty because while most of the solar plasma is fairly well contained in even larger arcs than the ones connecting sunspots, called coronal magnetic fields. Coronal holes, however, have fields that stretch out into space, allowing that solar wind plasma to blast out more powerfully. For this reason, they are the third way we get enhanced solar wind. Again, those three are big solar flares, plasma filament releases, and coronal holes. All enhance the solar wind that impacts the Earth. Solar wind is monitored at all times by several different satellites. From top to the bottom, looking at the solar wind data, we see the measurements of the magnetic field strength embedded within the plasma stream, then the magnetic angle of the field in blue, then solar wind density in the middle, plasma speed of the stream second from the bottom, and finally plasma temperature in green down below. The solar wind shows very different characteristics when you're looking at a CME versus a coronal hole stream. In this data, you can see how there is a jump in the telemetry factors all at the same time. That is the impact of a CME. However, a coronal hole stream doesn't change all the telemetry at once. These begin with the rise in density, and it is followed by a rise in plasma speed and temperature. This is because instead of a CME shockwave, a coronal hole stream is simply a faster stream in the solar wind that acts like a shovel through snow, piling up the density on the leading edge, and after that initial density bulge like snow on the shovel blade, the faster coronal hole stream particles arrive. Did you know that we can generally predict whether or not a sunspot group will erupt solar flares? In addition to visualization of the active region sunspots, their magnetism is seen by neutral iron characteristics in something called a magnetogram instrument on satellites. An alpha-class sunspot is dominated by one polarity, either red negative or blue positive, and they are least likely to erupt. Beta class have both polarities, and generally that classification is needed to get any kind of significant solar flare. Further enhancements are gamma and delta class. Gamma class is when you cannot separate the positive and negative sectors with a continuous line, when one is cut off from the rest of its like polarity spots. Here, in the middle, the blue positive spots cut the red spots into two groups, making it gamma class. And finally, delta class is when you get positive and negative closely interacting, basically bumping into one another. That's where you get the highest of all chance of bigger flares. Once a solar flare, or plasma filament, releases a CME, we can begin to diagnose its density, speed, and direction via the Soho-Lasco coronagraphs. The CMEs are very easy to see on these images and their direction of motion as well. The way you can tell if it's coming our way is by seeing what's called a halo eruption. When you see it going out to just one side, you can be pretty sure it's not aimed at Earth, which is the case for all of these shown here except for the bottom right corner. That one looks like a ring around the sun, and when that happens, we call it a halo eruption, and it is going to impact the Earth. So let's review some of this stuff using the March 2012 solar flare event. The sunspot that came through was very large and complex. It did have the magnetic complexity and the beta gamma delta class range. As it extended its arching magnetic fields, it had the type of interaction we discussed, causing a series of solar flares, one of which was very long duration and released a CME that's easily visible by the disruption in the corona around the flare point. The last GO coronagraph showed a halo eruption heading out in all directions, indicating that it would hit the Earth, and indeed it did, triggering geomagnetic storm activity over several days, which can be most easily seen by the KP index charts. Aurora were seen down to mid-latitudes, the Sky Terra satellite station was crippled and lost, and there was a 10x increase in cellular disruption, flight delays, and electrical fires reported in the United States and Europe. As most of our regular viewers know, the Sun releases a super flare event every 150 to 200 years, one big enough to cripple the entire world's electrical capabilities. The last one in 1859 was before there was much to destroy. That was 164 years ago, and so we're in the red zone for the next one, which is why it is now more important than ever to monitor the Sun. Estimates range from 60 to 90% of humanity will perish when we lose global power, since critical systems from water treatment and distribution to heating to hospital functions and transportation sectors would be disabled with nobody coming to rebuild, since it has impacted everyone at the same time. So if you see the power go out and there's no thunderstorms and your cell phone doesn't work and the sky lights up with aurora, you can bet it was the Sun. We're 164 years since the last great event of this 150 to 200 year cycle, so many of us are likely to see the next one in our lifetimes. We report on the Sun's activity every single day.
Frid och shalom. Jag vill ge er ett uppmuntrande budskap, ni som tror på Gud. Ja, vi ser ett system byggas upp just nu och många är faktiskt rädda och undrar hur ska det gå. Det står ju att det ska komma ett riktigt otäckt vilddjur och vi ser det ju nu framför oss. Hur ska det gå med märket? Hur ska det gå med oss? Och så vidare och så vidare. Här är vilddjuret, säger folk. Vem kan strida mot det? Uppenbarelseboken 13. Ja, det undrar vi också. Ja, Herren kan strida mot detta vilddjur och ska strida mot detta vilddjur. Han kommer nämligen att stjälpa allting vad vi håller för säkert. Både i himlen och på jorden. Hebreerbrevet 12 talar om att han en sista gång ska skaka. Inte bara himlen utan också jorden. För att vi som tror skall få ärva det som inte kan skakas. Guds rike med andra ord. Och i Lukas 21 och 24 så står det att så här. För att vi ska få en riktig uppmuntran idag. Tecken ska visa sig i solen, månen och stjärnorna. Tecken på vad då? Jo, på att Jesus Kristus ska komma tillbaka och fullborda frälsningen till en stor förlossning. Och på jorden ska folken gripas av ångest och stå maktlösa och rådlösa vid havets och bränningarnas dån. Det visste ni väl till exempel att solen och månen har mycket med tidvatten att göra. Och skulle det bli några förändringar här i dragningskraften så säger man att man skulle få bränningar och tidvatten på cirka 40 meter höga vågor. Till exempel om polerna börjar dra iväg och allting står på ända. Och det kommer att komma sådana strålningar alltså ifrån rymden här som slår ut all elektricitet. Människor ska ge upp andan och skräck i väntan på det som ska komma över världen. Alltså man ser det här ska komma och förstår det. Ty himlens krafter ska skakas. Det här måste ha med rymden att göra. Ja, då ska man få se människosonen komma i ett moln med stor makt och härlighet. Ni vet, han får ju upp i ett moln och på samma sätt ska han komma tillbaks. Men lägg nu märke till vad det står här. Men när detta börjar ske så räta på er och lyft upp era huvuden. Ty då närmar sig er förlossning. Vad är det han syftar på här? Som vi ska förstå med andra ord. Jo, tidstecknen. Vi ska förstå att Gud skakar inte bara jorden men också himlen. När alla andra inte fattar någonting, som dårar kommer människorna stå. Då vet vi tack vare denna bok, vad som händer på jorden, och vi ska inte frukta, hör ni det? Vi har nämligen en Gud som kommer att strida för oss och bryta ner det här systemet. Det kommer inte att lyckas och inte att fungera. I Jesu Kristi namn kommer det att bli tufft, men Herren kommer att segra. I Jesu namn, amen.